Hello and welcome to another one of D's AD videos. Today we're going to be looking at an example of Hess's law. So, when discussing Hess's law, what we're going to be doing is looking at step reactions to create an overall desired reaction. So I've written these step reactions in blue with their known enthalpies, and we're going to manipulate them somehow to create this other equation. So when we manipulate these equations, we need to get this final equation in red. So when I look at this, I ask myself, is everything on the right side? And right off the bat, I notice this Fe2O3, this iron 3 oxide, is going to be on the right side. Well, because it has to be on the right side, this equation must be reversed. So let's see that in action. So we're trying to create 3 from 1 and 2, and step 1 we reverse it. So when we reverse it, we're going to take the negative of your delta H. And then step 2 would be to multiply this equation by 3, because we need to have a 3 halves for the oxygen, the O2, and here I have a 1 half. Alright? And look at the coefficient for that CO2. It needs to be a 3 to cancel out with this 3CO2. So this would need to be a 3. So also here we have a 3 carbon monoxide that would need to cancel, so this whole equation would need to get multiplied by 3. So the delta H would also need to get multiplied by 3. So this is what's happening to the delta H. Now let's see the actual processes. So reversing the equation would make these products now reactants and these reactants now products. Again, we took the negative of your delta H as a result. So then the next step was to multiply your second equation by 3. So here's that 3 times. And now you have to multiply your delta H of 283 by 3 as well. Now we can add the 2 equations, and when we add the 2 equations, we'll be left with products and reactants that have the same thing that will cancel out. Again, make sure the state is the same of gas and gas, and the carbon dioxides will cancel, leaving you hopefully the desired equation you have. At that point, all you do is just sum up your delta H's. So when you do that for this problem, you should get a negative 822.3 kilojoules. Because it's negative, we know it's exothermic. Heat is released. Alright? So this is just a basic example of Hess's law to get you started. Practice, practice, practice as always to become proficient at this stuff. Watch intermediate and advanced examples as well. Thank you and have a nice day.